And welcome back, and it's a new month. It's the 1st of May, further maths 5 a day, and let's go with the first one. Right, what do we have? Shown below is a cube with side length 10 centimeters. Work out the length of BH. Okay, so the first thing to notice is BH is a diagonal straight across. Now, because this is a further maths question and not just a normal maths question, I'm going to assume you've come across 3D trigonometry. So the way that works is that involves recognizing that the way that I do this is I do the square root of a squared plus b squared plus c squared. In other words, this is a cuboid, so all my lengths are 10, so this is going to be the square root of 10 squared plus 10 squared plus 10 squared. And that's come from the idea that in order to find out this length here, I'm doing 10 squared plus 10 squared, and then in order to find out the diagonal, I'm combining it with this 10 squared here. So in other words, I'm doing 10 squared plus 10 squared, it cancels out. I can do it all in one go. Either way, calculator out, or actually even without a calculator, I've got 3 lots of 10 squared. I can take a 10 to the outside, and that's going to give me 10 root 3. Now, if I do get my calculator out, because it doesn't tell me how to answer the question here, so I'm probably going to give both answers, or both answers will be acceptable. So I'm going to say 10 root 3, which is approximately 17.3 centimeters. First question of the month done. Next question. P is the point 7 minus 5 on the circle. Now, as I often do, I'm just going to, just so I get it straight off and I don't make a silly error, I'm going to write down my center, which is going to be 5 minus 3. And then I'm going to note my radius is not 8, but my radius is the square root of 8, which I know is 2 root 2. Root 4 times root 2, 2 root 2. And then it says work out the equation of the tangent to the circle at P. Okay, so P is the point that I'm given here. And so basically the way I'm going to do is the normal process. I'm going to start by working out the gradient that gets me from the center to P. So my y values go from minus 3 to minus 5, in other words, down 2. My x values go from 5 to 7, in other words, up 2, which means my gradient is minus 1. So far, so good. However, that's the gradient of the radius, and I want the gradient of the tangent. So the gradient of the tangent is the perpendicular to that. So the negative reciprocal of minus 1 is just 1, which means that my tangent has the equation y equals x plus c. Now, again, I know it goes through point P, so I'm going to put P into my equation. So minus 5 is equal to the x value, 7 plus c, which means that c, well, I want to get from 7 to minus 5, so I'm going to have to take away 12. So therefore c must be minus 12, which means my equation is going to be y equals x minus 12. And that is that question done. Okay, so this next question, nth term of a sequence, is a quadratic, because I can see I have n in my nth term. And it says, by using completing the square, show that every term is positive. Well, this is a clever question, because this links something which I don't think we always explicitly say, but it's important you sort of get your head around, which is the nth term of a quadratic sequence looks like a quadratic because it is a quadratic where we just have integers that go into the n value. In other words, I only consider various values of input rather than all values. But I can still use the same technique, which I can complete the square. So that's going to give me n minus 4 squared minus 16 plus 31, which I can simplify down to n minus 4 squared. Well, minus 16 plus 31 is plus 15. And then I just want to make a clear argument. You don't have to explain it at length, but just that is greater than 0. Upside down, A means for all, so for all values of n. And therefore, just put the conclusion. So therefore, show that every term is positive. So I'm just going to say, therefore, every term is positive. I've made an attempt to show why it's greater than 0. I haven't really talked at length about the squaring process, but again, this is marked by people who know maths. They're just looking for you to show that you know it as well. Next question. The next question says, in fact, let's scroll all the way up. The next question says, prove that, and then it gives me a tan squared and a cos squared. Now, almost always, not always, but almost always, it's going to involve turning the tan into sine over cos. So that's sine over cos theta, and these are both squared, and I'm taking away 1 minus cos squared theta. Now, you'll notice I'm starting with a left-hand side. I'm not writing down the minus 1. I want to turn it into a minus 1. Then what I'm going to do is I'm going to clearly show this is the same as sine squared theta minus 1 over cos squared theta, because the denominators are the same. Sine squared minus 1. Now, because it's a proof question, I might just write over here that 1 is equal to cos squared plus sine squared. Just shows I know what I'm doing, which means that sine squared minus 1 Well, 1 minus sine squared is cos squared, so sine squared minus 1 must be minus cos squared theta over cos squared theta. And that is equal to minus 1, which is equal to the right-hand side, and so therefore proven. Lots of steps, clearly showing what I'm doing, and I've written down my identity as well. Next question, and indeed final question today. Now, we've seen one like this before, haven't we? So the first thing I'm going to do is split it into two fractions. So in other words, that fraction and that fraction there. So let's do the one on the left. So 4x7, well, the x is x7 over x is going to be x6, and 4 over 2 is 2. And then it's minus. Now, x5 over x is x4. And the key thing is that is not a 2, that is a half. So it's going to be a half x4. Then I'm going to differentiate. So dy dx is going to give me 12x, 6 minus 1 is 5. And then bring down the 4 is going to be 2, so that's going to be 2x cubed. And that is my first differential. However, it wants a second differential. So differentiate again, so d2y dx squared. And that's going to give me 60x to the power of 4 minus 3 times 2 is 6. So 6x, take away 1 squared. So my final answer to this is going to be 60x to the power of 4 minus 6x squared, and that is today done. First day of the month, not too bad at all today, actually. Pretty straightforward. Let me know how it went for you. As ever, like, subscribe, and I'll see you for the next one.